Hi team, this is another video on Snowflake. The subject of today is machine learning models using Python user-defined function. The use case is sales forecasting. So there is no data movement. We will use Snowpark data frames and Panda data frames. We use also Python with the auto Arima model. We deploy the model as stored procedure in Snowflake, and we explore the results via Snowsight and Matplot graph. The code usage is from Chris Hastiel, so I adjust a little bit this code, and this is the GitHub for this use case. The Snowpark data frame API and Python function. Here we have the integration from the client side and server side. We have the query translator for the SQL statement, and for the Python code also we have an object serializer, and the SQL will be executed with the SQL engine, and the Python will hit the Python secure sandbox. It is highly recommended that for local development that we need to upload packages and libraries from Anaconda because it is certified, and when you deploy to Snowflake we will avoid the mismatch of version, and this issue is a classic issue, so just please be aware that before local development, when you need any package, go to Anaconda repository and upload it. Here, an example of end-to-end machine learning, the classic workflow. We have the prepare and the transform of the data. We train the model and we do the prediction with the inference. We use Arima time series forecasting model. It is a linear regression model that calculates difference between the current values and the prior values to have stationary model, and it move average of prior error to have optimal result. Here, the workflow of the detailed tasks that we will see in the demo for the data ingestion, for the data transformation, for the prediction, and to review and explore. And finally, we deploy the model as stored procedure. On the database side, we have 4 schema, one for staging the raw data, one for the clean to clean the data, and one mart schema for the target data, and we have a procedure that will contain the generated excuse me, model. So from the S3 stage CSV file, we will prepare that, load that into a table, and we will continue the steps of the process. We will explore the data via Snowsight. I'm using here sorry, Visual Studio with a Jupyter Notebook extension. So let's start here. We connect the Snowflake. So the connection is successful. I'm using a JSON file to connect with the credential of Snowflake. Clear out. So here we reference the source data, and we display with Snowpark API session table and session data frame Snowpark show. Here we import the required packages for the transformation. We will filter the data here with filter and the data on the year and transformation on the sale date to have the years greater than 2005. We aggregate the data here, the group by according to the Snowpark syntax. We need to convert the sales date to the first of the month, and we will group by this column with the category, and the aggregation will be sum, and we will have only this selected column, sales month, sale month, and category and sales, the metrics. We can sort the data also. By default it is ascending. And finally we need to write the data to back to Snowflake in the clean schema and the product sale table, and we can verify with the show the reference table that all is okay and the table exists in Snowflake. On the second Jupyter Notebook, we need to import the required privilege, Panda and PDMD Arima, to create the model, and of course, Snowflake Snowpark. Here we connect Snowflake again because it is independent Jupyter notebook. Here we need to initialize two variables with the target origin table and destination table. Here we need to reference the tables, the original one. To convert here this subset of code, we will convert the Snowpark data frame to a Panda data frame to have more functionalities. Here we convert the date time and find the filter a single category for this sample data. We use only the filter here on the category equal to enterprise. And here we will create the predict model. So first we need to just split the data to a data frame for training and a data frame for test. And we will use only the last 2 years for the test, and the prior to these 2 years will be sorry, for the model training. So let's do that. Here we will create the auto Arima model. So as a data scientist, you will adjust the parameter and iterate the training phase to get the optimal model. But here, auto Arima, it is auto self-tuned and auto hyper-tuned. So this model will generate a subset of models and it will select the optimal one. I will pause the video because it could take up to 3 minutes. So let's start. We'll pause the video. So the generation of the model, it took more than 4 minutes. It is executed locally. Just connect trained and test data. So here we have the best, the optimal one. It will be the one who has the lowest value of AIC, which is a factor to balance model complexity with the amount of the error. And here we have the Arima, the best model is Arima, this reference. So now we just summarize the model and we generate in sample prediction. In sample prediction is prediction on the same data that we trained. Done. So we have the train and the train prediction and the difference here. We generate prediction on the test data now. This prediction is not. We pause the video just to. So here we need to summarize the model. It is already done and generate in sample prediction. So we try just to. This is the train. This is train. Trained prediction and the difference. Here we need to combine test and the prediction with original, and we need to write the output back to Snowflake in the MART schema and the sales DB table. Here we review and explore the content. Here we use this sample code. Just as you can see, the blue is the train and the orange or the yellow, it is the train prediction. As you can see, most of the point matched. And this is the percent of the error. And here we compare the prediction with the whole test. As you can see here, the blue, it is the trained data. The yellow, it is the test. And the green one, it is the prediction. So the last portion is just to encapsulate all this code and create a user-defined function. We just import the required package here, connect Snowflake. Then we need to create the stored procedure, create the function. Here it is user-defined function, create it locally, and then we will package this just to import package and add packages, convert the function to a stored procedure on Snowflake with the syntax to register the return type, the input type, and it is permanent, the name, and the stage here for the stage location to encapsulate the zip file. Here we need just to execute this code, and we will see on the Snowflake side that stored procedure is already generated. Here show just because we need to check that the procedure is created. Show for the result here should have. So here the procedure is successfully generated. Here we need to call the function, which is the model with the product sales and the product sales percentage. This is the origin table and this is the target table. So to do the call on Snowflake side, since the model is already deployed using this stored procedure, here just for the setup, we have the setup SQL. I forget just we create the sales database, we create the schema, the stage, the format files, and all the required stage, and the copying the command just to copy the content of the file from the stage to Snowflake. So here on Snowflake side, I'm using X small warehouse. So maybe if the size will be resized, the response time will be optimal. But since it is my free trial, I want to keep extra small. So this is the first possibility to deploy a model as a stored procedure. We have also some announcement from Snowflake just to get the Snowpark model registry. So here, what is integrated solution to manage deploy model and their metadata natively in Snowflake. So we can register the model, log it in the model registry, and then create a deployment. So we can use some versioning also for the deployment. And this is, I think it is in a public preview. And also with the service container, we will have any code that can be encapsulated in a container as such a Docker and will be also registered into a container repository inside Snowflake. So now when we say Snowflake, it is any source, any code that can be deployed. Here the procedure is successfully done. So just we need to display. We can chart ability. We add the column sales prediction, test prediction here, and for the month can maybe the month. And here we can see that for the sales this is the actual and this is the prediction, and you can see that there is maybe perfect matching with the prediction. So that's all for today. Thank you very much for watching this video, and hope see you in a next video. Have a nice day.